Hi, and welcome to today's webinar on Automate Everything, Appium 2.0 and new drivers. My name is Jason here at HeadSpin, and we're thrilled to have you join us today. We're excited to have Jonathan Lips back with us again. For those who don't know Jonathan, Jonathan is the architect and project lead for Appium, the popular open source automation framework, and is also the founding principal of CloudGray, a consulting firm helping customers successfully leverage the power of Appium and the author of appiumpro.com. We want this webinar to be interactive, so if you have questions anytime during the session, please type them into the question box in your GoToWebinar control panel. We'll have some time to address them at the end. Last but not least, this session will be recorded and sent to all attendees, so look out for the email. So without further ado, I will turn it over to you, John.
Thanks a lot, Jason, and good morning, everyone, or good afternoon or evening or midnight, depending on where you might be in the world. I'm really excited to be here in what is my morning, talking about Appium drivers and Appium 2.0. So Jason already gave a very complete introduction for me, so I'll just add this picture. I'm even wearing the same hat today. So this is in fact what I look like, and I do work on Appium, both the open source side as well as helping my clients be successful with Appium and mobile automation. So today we're going to have a brief introduction and tour of 4 drivers which are part of the Appium driver bucket that you might not have used before. We're going to talk about the Espresso driver, the Windows driver, the macOS driver, and the Raspberry Pi driver, which is for testing IoT devices. That's definitely the most out there of all the ones we're going to look at. And of course, we will also touch on Appium 2.0. I've been working on Appium 2.0 a little bit, and I thought it was time to start circulating my ideas about what Appium 2.0 is, what's its kind of vision, and what are some of the technical possibilities and changes that you might expect when it's released sometime next year. So first of all, let's drive a little bit beyond mobile. Let's go beyond the typical Android and iOS drivers that you probably use with Appium and talk about some of the other possibilities. The basic idea here is that Appium uses something called the WebDriver protocol to facilitate the communication between your test script and the Appium server, which then ultimately performs the automation commands that need to happen. The WebDriver protocol, as you can tell in the name, was originally designed for automating web browsers. And, it's already the case that Appium uses this same protocol to automate mobile applications. We simply extended it in a few ways and added some additional capabilities. But by and large, if you look at an Appium test script, it looks and reads very similar to a Selenium test script. So the question is, why not go further? Why not go beyond mobile to other types of applications? When you get right down to it, applications, are pretty much the same regardless of the platform. Whether an app is running in a web browser or on a mobile device or on a desktop or laptop computer, they pretty much work the same way. So that is in fact what Appium has done with some of these not so well-known drivers. We've extended the WebDriver protocol to support many other platforms, including desktop applications. The really nice feature of this capability of Appium is that you can write your test scripts in any language, mix and match them with any framework, and now target pretty much any platform that's out there. Whereas, of course, if you wanted to automate, Mac outside of Appium, you would be looking at hacking together your own system events, accessibility scripts, and things like this, which would work, but then they're not going to have anything in common with scripts that you might already have for the web version of your app or the mobile version of your app. So you get to leverage a lot of knowledge, a lot of code, and a lot of framework infrastructure, and reuse all of that stuff when you rely on Appium as your automation framework. So that's part of Appium's vision. So let's look at some of these drivers and what they can do. First of all, let's talk about the Espresso Driver. Now, Espresso is the latest Android automation framework from Google. It's not very new anymore. It's been out for years now, but it is the recommended approach for automation of Android applications from Google. So if you're just an Android developer using Android Studio and just reading the Google developer documentation, you'll see a lot about Espresso and using Espresso to automate your app for testing purposes. Key things to understand about Espresso. First of all, Espresso relies on a gray box testing model rather than the black box testing model that Appium usually uses with all of its other platforms. So the difference here is that a black box testing model means the automation comes in kind of from the outside, treating the application as a black box, and it can only do the sorts of things with the application that a user can do, like tapping on elements or reading things off the screen to get information about the state of the application. It doesn't have access to the application internals. Now, in gray box testing or white box testing, application internals are available to the test script. So the test script is running in a context where it has access to the application source code and can therefore trigger different commands or get different information about the state of the application from inside of the application itself. It's like being able to look a little bit into the application and do some things there. Another great feature of Espresso is what's called idle synchronization. And this helps to address a huge problem in any kind of UI automation, which is that the automation is often trying to do things when the UI is not actually in a resting state. So if you've ever encountered, element not found exceptions, it's probably because your test code made an assumption about the state of the application and the application hadn't, painted that view yet or hadn't navigated to that web page yet. In other words, the application was doing something when you tried to interact with it and it wasn't ready. And a human user, uses their eyes and their brain to detect when, an application is doing something. Either there's a spinner or maybe in a browser, the little loading progress bar is still going across the top of the page. Or maybe they're looking for a specific element and it's not there yet, so they're just waiting for it to show up. What Espresso does is it actually detects when the application is in the middle of doing something so that it knows that the application isn't quite ready for user interaction. So if you send in a command to Espresso while it's waiting, it just kind of keeps that command and doesn't execute it until it's actually ready. So this helps add stability and robustness to tests because they don't experience the same kind of flaky errors due to the app state not being what you expect. And there's some complexity here, and Espresso doesn't know about all the different ways that your app could be busy. So sometimes you have to teach it when your app is busy so that we can take advantage of this idle synchronization. But it's a nice feature. One of the other takeaways for Espresso is that because it is tied in with the application itself, it is isolated to the app under test. So you can't use Espresso to automate all aspects of the device UI, the home screen and things like that. For that, you would need to use the existing UI Automator 2 driver, which works by automating the accessibility layer of the device, which is kind of a layer that sits above all the applications. So it's not tied to any specific application. With Espresso, we also have access to some advanced ways of getting a hold of elements. We can even find elements that haven't shown up on the screen yet if they're part of a data set that is bound to, for example, a data grid or a list view of some kind. We can also find elements by a view tag, which is an Android-specific piece of information about elements that can be added by developers. This is especially helpful for React Native because React Native puts the test IDs into the view tag on Android. And right now, the Espresso driver is the only Appium driver that actually gives you access to the view tag of an element. If you want to use the Espresso driver, these are the kinds of capabilities you need to worry about. Basically, it's just like any other kind of Android automation capabilities with Appium, except for you need to make the automation name equal to Espresso. On this screen, we have an example of a command which is only available on the Espresso driver. So if you look kind of in the middle of the screen here, we have something that reads driver.execute script, and we're executing this Appium script mobile:\backdoor. This is the backdoor method, which enables us to get inside of our application code and call methods internal to our application that a user would never see from the outside. So this is kind of what I was talking about earlier with the gray box testing model. This is how Appium gives you access to this gray box aspect of Espresso. So in this case, to figure out what we're actually trying to do in the application, we can take a look at the script args variable here, which is basically just a big map of maps. And we're basically saying we want to call a method that exists on the application. The method's name is called raisetoast. So if that's appropriately named, it's going to show some message on the screen. And the argument that we are passing to this method is a string, and it has the value hello from the test script. So if you look down at the very bottom line, you'd see what we would write in Java if we were writing code inside of the application that leverages this raisetoast method. We'd basically, be calling the raisetoast method on the main application Java class, and we'd be calling it with this string argument. So the script args variable above is just our way of encoding all of that information as a way to pass it to Appium so that it can then, call it within the Espresso context. So I'll just show you a little video of what it looks like when that code is executed. You can see it happened really quickly, but we saw this little hello from the test script message pop up. So let me see if I can show you this again. So my app very quickly pops up, and then we get this message, hello from the test script. That was not triggered by any kind of UI interaction. It was triggered by directly calling that method internal to the application using the Espresso driver. If you want to learn more about the Espresso driver, I have an article about it, specifically this backdoor method, appiumpro.com. It's edition 51. Okay. Let's talk about the Windows driver. The Windows driver is pretty awesome in that it's actually powered by a tool provided by Microsoft itself. So Microsoft decided to build an Appium compatible automation tool. They call it WinAppDriver. So the Appium Windows driver is basically just a very small bridge to WinAppDriver, which is maintained by Microsoft. Actually, it's up on GitHub, so you can go and check it out and ask for improvements if you want. Some key things to understand about the Windows driver. First of all, it requires developer mode to be turned on the machine or for your user as you're logged in. It also requires Appium to be run in a console which has administration privileges. So you need to do the whole trick where it's like hold down Command or Option as you type in the command prompt in the Windows Start menu. I don't remember specifically, I don't use Windows every day. Some of these instructions are available online, but basically you want to make sure that whatever you're running Appium in, whether that's the typical command prompt or PowerShell or some kind of bash equivalent on Windows, you need to make sure it has admin privileges. The way that you launch applications with the Windows driver is by an application ID. So usually with Appium, you pass a path to the application on disk, but this doesn't work for the Windows driver. Instead, every application that's installed and registered with the system has a particular ID. And these IDs can look pretty crazy. They're kind of unique ID type things. So I found this command that you can run in PowerShell called get start apps, and it will list all of the apps that are available and each of their IDs. So if you want to, automate a particular application, run this command and then look for it in the list, you can get its ID. As far as I know, these IDs, especially for Windows applications, are the same across all Windows installs. It's not like they differ from computer to computer, but they're unique, I guess, in the world of Windows applications. The other thing to be aware of with automating Windows applications is that apps don't really have something called an accessibility ID on Windows, but Microsoft, Microsoft implemented this attribute called automation ID, which is specifically for WinAppDriver and other automation tools. So it's pretty nice that they built this in. So if you, get your page source of a Windows application and you look through it and you see an attribute labeled automation ID, you can find the element with that attribute using Appium's accessibility ID command. So driver.findElement by mobile by .accessibility ID and so on. That's how you would use that. So for the Windows driver, the capabilities look something like this. Platform name Windows, platform version 10. This only works, I believe, on Windows 10, although it can automate Windows apps which are quite old. I think it has to run on a relatively new machine. Device name is Windows PC, and then here's an example of an app. In this case, it's the weather app that comes with Windows 10, and this was the ID that I found using the get start apps command. And this is what a test could look like of the weather application on a Windows machine. You can see it looks basically like any other Appium test. We're finding some things by accessibility ID, some other things by XPath. This particular test is trying to find the different days which are displayed in the weather application and get some information about each of the days. For example, the sunrise and the sunset of that particular day. And when we run this example, it prints it out to the console. So it's kind of a way of, you could think of this as like RPA for Windows, getting some weather data from the weather app. Obviously, there are more efficient ways to get weather data. We could use an API, but this is a fun demonstration of Windows automation. So if you can see, this is actually what it looks like when it's running. So we actually tap through each of these different days, and then you can see sunrise is down in the day details. So that's what we're then scraping off as we tap through each of these different days. If you want to learn more about Windows automation and get the full code for automating that weather app on Windows, check out Appium Pros Edition 81. Okay, let's move on to the macOS driver. The Mac driver, as we call it, relies on the system accessibility frameworks to give control over the entire desktop. So basically, macOS comes with this system events framework that allows applications to basically see everything that's on the screen, to interact by moving the mouse or by clicking on different things. So it's actually a very powerful kind of automation. However, the downside is that apps have to be specifically given the permissions to control the computer in this way. This is really good, obviously, for security purposes. You don't want random applications controlling your computer without your knowledge, but it does mean that there's some manual setup that's required to make sure that Appium has the ability to automate the system in this way. So key things to understand about the Mac driver. First of all, there is an actual Mac application a .app that runs on a Mac called Appium for Mac, and this has to be manually installed and downloaded and installed, I should say, and put into your applications folder. Appium for Mac must also be granted accessibility control over the system. And it's actually not just Appium for Mac that has to be granted accessibility control, but whoever is the kind of parent process of Appium for Mac. So if you're running Appium from the terminal application and you're running a Mac test, then Appium will be running inside the terminal, and it will attempt to start Appium for Mac as a sub-process. So the actual parent process of Appium for Mac is the terminal. That means you have to grant the terminal accessibility control over the system. So this is, of course, something you may not want to do on your own machine for security reasons, or you might want to turn it off, because if the terminal has accessibility control over your system, then you could imagine if somebody tricks you into running a malicious script in your terminal, outside of your knowledge, something might happen on your machine. So again, security concerns if you're trying to run this on your own machine. But of course, as with any type of testing, it's important to consider your device under test to be something separate from your development and test development workstation. So you probably want to have a separate Mac Mini lying around, or use Mac Stadium or something like this in order to actually run Appium tests. And then, you might not care so much what happens on that system, or you can find ways to ensure that malicious things don't happen using networking protocols or keeping it internal to your local office network or things like that. Okay, so the way that you open and launch applications with the Mac driver is simply using driver.get. So instead of putting a URL for a web browser, we're putting the name of an application. So if I say driver.get calculator, it will look for calculator.app in my applications folder. So that's pretty simple. One other wrinkle about the Mac driver is that there's really only one locator strategy, which is XPath. And while in your test code, you'll be writing things like driver.findElement by XPath, the actual flavor of XPath, which is used by the Mac driver, is something called absolute XPath, or AXPath, as we say it. And what this is XPath without any relative nodes or queries or searches. So basically, every XPath query must be fully qualified. So I'll show you an example of what this looks like. What this means is that finding elements, the actual selector for the different elements can be quite long and quite tedious, and in some cases potentially quite brittle. So you have to do some imaginative thinking to make sure that your XPath locators are going to be robust. To figure out what the locator of an element is, there's a special feature that Appium for Mac has, where if you have it loaded, you can put a mouse pointer over any element on the Mac OS desktop or operating system or other applications, and hold down the function key for a few seconds, and it copies a AXPath for that particular element to the clipboard. So capabilities for this driver are pretty straightforward. Platform and device name should both be Mac, and if you want an app to start automatically, you can just put its name as the app capability. Here's what a sample test looks like for the Mac driver. I'm testing the activity monitor application in this particular example. So you can see that I have a bunch of strings here where I'm defining AXPath selectors by kind of building them up from a base accessibility or absolute XPath. So the base AXPath in this example is AX application / AX title equals activity monitor / AX window. And that AX title equals activity monitor portion is extremely important, because that is what ensures that all of my other selectors, which I build off of this kind of base string, that's what ensures that they all take place within my application and not within some other application. So then I've got something called a tab selector template, which helps me to select different tabs in the application. So the different tabs like memory, energy, disk, or network, or CPU. And you can see again how I'm using this XPath filter, making sure that the accessibility title of that particular tab is, memory or energy or disk or network or CPU. So this is a pretty reliable and robust way of finding these elements time and time again without relying completely on their position within the application. So all I'm doing in this little test is tapping through the various bits of the activity monitor application, and eventually I am, typing something into a search field and then getting the text of that search field and asserting that it is kind of what I ultimately typed into it. So it doesn't really do anything particularly useful, but you could see how you could potentially automate applications in a useful way using these commands. So here's a little example. Tab through all the different aspects of the activity monitor and then typed into the search field. So this was us controlling a Mac application using Appium. If you want to learn more about this, then check out Appium Pro's edition 52. Okay, let's move on to our last driver of the day, the Raspberry Pi driver. So this is kind of a special one. The idea behind this driver and other drivers that I hope are developed that are similar to it is that applications don't actually always have user interfaces. What about IoT devices? These are physical things that take some kind of sensory input, whether it's electrical or pressure or temperature or moisture or anything like that, and use that input to send data to something online or control something in your house using a feedback system. So these are not traditional devices with user interfaces, but of course they could still be tested, and they could still be tested in an automatic fashion. So why not use Appium to do this? So this was kind of the experiment that I tried to do for myself when I was developing my presentation for Appium conference earlier this year in Bengaluru in India. So what I did is I took this little device here. This is called a Circuit Playground Express from Adafruit Industries. And this is basically a little hackable circuit board that has a bunch of sensors built into it and can do different things like turn on or off a light or output some sound, things like that. So I basically thought, okay, I want to figure out how to test IoT devices with Appium, but first of all, I need to have an IoT device to test. So I need to build some kind of IoT device to begin with. So this is what I did. I built this little drum machine. It basically, when I tap those different buttons, the light changes on the Circuit Playground Express, and also you can't hear it on the webinar, but some sound is emitted from the headphone jack. Actually, it's not a jack, it's one of these little electronic pads that we can connect a headphone to with some wires and things like that. A little drum sample is played when I hit each of these buttons. So I've got a kick, a snare, a hi-hat, and a tom that are attached to these different buttons. So it's a little drum machine, basically, that I developed. So then I asked myself, okay, I've got a drum machine. Now how would I want to test this? Now, there are a bunch of ways to think about testing this. There's obviously software running on the circuit board, which I wrote, that I could just write some other software that would, send the same commands as the real software does whenever it waits for someone to tap the button. So that would be kind of like one layer of testing. But I wanted to go a layer more real. So what I thought is that each of these buttons works by changing the electrical signal that is going into the Circuit Playground board. So whenever I tap one of the buttons, I think the way it works with this particular design is that a circuit is broken, and the Circuit Playground Express software is listening for that circuit to be broken. And when it's broken, it emits the appropriate sound and changes the light. So I thought, I don't need to physically tap a button to make this happen. I could just send electrical signals into the same points on the circuit board, and whether that signal counts as a high or low signal will then cause the Circuit Playground software to believe that a button has been pressed. So this is kind of like a functional approach to testing a circuit board, actually sending in or removing real electrical signals from the physical ports on this board. So to do that, I got something called a Raspberry Pi. And a Raspberry Pi is a little computer that's just printed on a circuit board. It's pretty awesome. I recommend playing around with them. The important part about this Raspberry Pi is it has something called the GPIO header. It's up at the top here. It's in 2 different rows of pins. And GPIO stands for General Purpose Input Output. So these are just pins which the Raspberry Pi can use to send electrical signals through. So what I wanted to do was take this Raspberry Pi and basically connect wires from the little pins here to the ports on the Circuit Playground circuit board, and then basically have the ability to send electrical signals from the Raspberry Pi, mimicking me actually pressing one of the drum machine's buttons physically in reality. So what I was able to do then is develop an Appium driver for the Raspberry Pi that lets me write an Appium test to say when these different pins on the Raspberry Pi should emit or stop emitting electrical signals. And by doing that, I was able to construct an Appium test script that drove the Circuit Playground IoT application of a drum machine without actually having to tap the drum buttons themselves, but also without kind of mocking the connection. I'm still sending electrical signals the exact same way that tapping the button would. So let's see a little bit what this looks like. This is the script that I wrote to play a little song. You can see there's just a bunch of, I can pause this before it goes on too much further. You can see I'm actually just using a JavaScript driver here. I'm attaching to an Appium server running on the Raspberry Pi itself. And I've got all these helper methods for playing a song based on which pins are associated with which drum sounds. So in this case, I'm finding elements by ID. These are the elements that correspond to the different I/O ports on the Circuit Playground Express circuit board. And I'm basically just, making electrical signals either go into or not go into those ports by using the send keys command. So I can send a 0, which means no signal, or I can send a 1, which means signal. So that's basically how this works. Let's see. Now what's happening is in the other terminal window, I'm starting up the Appium server on the Raspberry Pi itself. And here's a video of how it's all connected. So I've got the wires coming out of the Raspberry Pi connected on top of the other wires coming from the buttons, because I'm not modifying my app under test. And now I'm running my test script. And you can see that as the commands are being called, the different drum lights are being activated, and we can't hear it, but the different drum sounds are being emitted as well. So that was how we ran an Appium test of an IoT device using electrical signals, a Raspberry Pi, without modifying the drum machine device under test. So that was pretty fun. Key things to understand for this Raspberry Pi driver is it's not an official driver yet. It basically runs in standalone mode. It runs on the Raspberry Pi itself. So you actually have to, install an operating system on the Raspberry Pi and clone and build this driver in Node.js. You have to have Node.js installed as well. The idea of an app is a bit different in that there's no software application. Instead, what we're doing is defining a set of electrical inputs and outputs. So the app capability is actually just a JSON object which defines which pins have which names and what their initial states should be, whether they should be high or low. Then we can use driver.findElement by ID to find a pin by the name that we gave it in the app capability. And then all we do is we send a 0 or 1 to that pin using send keys to set the state of the pin to low or high. So it's pretty simple. There's not a whole lot you can do with electrical signals like this. If you want to read the full scoop on this, I've got 2 editions on Appium Pro starting at number 74. Okay, now let us wrap up by discussing Appium 2.0, and then we can take some questions. The idea behind Appium 2.0, in my mind, the big picture is that Appium goes from becoming a tool, an automation library, to becoming a platform for a whole automation ecosystem that spans devices and platforms and frameworks and everything else. So the idea is that moving forward, Appium itself is going to be this one small piece of the puzzle. And then we'll have many different drivers and many different plugins, all of which have their own independent existence and development trajectories and everything else. But they are integrated with Appium as and when you need them to be. So they're not all bundled together into one big package the way that they are now. So with Appium 2.0, we'll have a whole new set of command line instructions you can run. For example, you'll have the set of Appium driver commands. So you'll be able to list which drivers are installed or available to install. You'll be able to install a specific driver from the standard repository or from anywhere on NPM or anywhere on GitHub or anywhere on your local file system. You'll be able to uninstall drivers. You'll be able to update them. So you'll be able to take just one driver, just the XCUI test driver, and say, okay, Appium, update this driver to the latest for me. But the UI Automator 2 driver, I like it how it is. I don't want to upgrade to the next version of that because it has some breaking changes and I'm not ready for them. So just update this one driver for me. So the idea here is that Appium's different drivers are for completely unrelated platforms. They have completely unrelated development cycles and different technologies that are used in their development. So they shouldn't really be bundled together in a way which, combines a certain version of the XCUI test driver with a certain version of the UI Automator 2 driver, the way it is now in Appium, because those are just unrelated things. So they should be able to vary with respect to one another. We also will have a command to verify your driver manifest to make sure that all the drivers that Appium thinks are installed are actually installed, and so on. So let's talk a little bit more about the new driver model for Appium 2.0. The basic idea here is that not just the Appium team, but anybody can create and publish a driver that anybody else can use. So right now, if you want to create a driver for your team to use, you can do that, but then you have to modify Appium source code to get it plugged in, or you have to convince the Appium team that your driver is useful enough to be considered one of the standard drivers that's a part of Appium. And so the Appium team has been, hand importing and coding connections to those drivers into the Appium source code, and that's not going to happen in the future. Instead, the Appium team will just maintain a list of supported drivers and what their names are. So the official drivers will just be a list that everybody will be able to install by name, but that doesn't keep you from installing anything else, any unsupported or unofficial driver as well. So as I said before, any driver that you create would also be installable from NPM, from GitHub, from any other Git repository you have access to, or even the local file system. If you just have a driver that you're playing with or that you're distributing as tarballs around your team or something like that. Also, as I said earlier, drivers will have their own independent versioning unrelated to Appium versioning. So the main drivers right now are versioned separately. So XUI test driver has its own version and UI Automator 2 driver has its own version. But when we release a new version of Appium, one particular version of each of those drivers are bundled in, and that's what you get when you install Appium. And this is not what we want to happen. So that's why Appium itself will not come with any drivers by default. And so you'll just, whenever you npm install Appium, the next thing you'll do is Appium driver install, XUI test, and then you'll get that driver. And if you need more, you can install more, but that's the basic idea. In addition to drivers, Appium 2.0 will also have the concept of plugins. And I'll say a little bit about plugins here in a moment, but they'll basically have all of the same commands available as drivers do. So anybody will be able to write and publish plugins that will be installable using Appium plugin install and friends. So what are plugins? Plugins basically let you add arbitrary functionality before and or after Appium commands. So if you think about the find element command, you could write a plugin that when the find element command comes into Appium, instead of sending that command on to the typical driver, you do something else with it. So for example, a plugin that I developed a while back allows you to search for an element by a semantic label, and then a machine learning model is employed to figure out which elements might match that label based on their appearance. So this would be an example of a plugin that would just kind of pay attention to the find element command and add additional functionality before or after that command. Plugins can also modify the Appium server itself. So if you have an idea for totally new commands that you would like Appium to have, and you want to write a little client to access those commands that you distribute among your team, you can also add routes and handlers to Appium itself. As I mentioned before, plugins will be distributable and installable in all the same ways as drivers are. So if you have it up on GitHub, anybody will be able to install it. Or if you have it up on NPM, anybody will be able to install it. So basically, you can think about plugins as tiny pieces of functionality, which can be small or they can be large, but they can be shared with others, and you can mix and match them with a variety of other plugins. So you can choose which plugins are active at any given point in time in your Appium install. Of course, just like drivers, plugins will need to implement a very specific interface that Appium documents in order for them to be compatible with Appium. And there's a lot more to think through with plugins. This is still very early days. So once we actually have a beta out, I certainly hope that a lot of people will jump on the opportunity to develop plugins so we can figure out what's not working, whether there are any security concerns we need to be worried about, whether there are additional types of plugins or plugin features that need to be enabled in the plugin interface to help people build what they want to build. There's a lot that needs to be worked on, but this, in my mind, is one of the most exciting things coming up in Appium 2.0. Of course, since it's the first time we'll have bumped Appium's major version in, I think, 5 or 6 years. I can't remember. I think it was 2014 we released Appium 1.0. So yeah, it'll be 5 or 6 years. We'll also squeeze in any breaking changes that we need to. And it will be easier to make breaking changes in the future and also respect semantic versioning, because each of the different drivers that the Appium team maintains will be on their complete own versioning scheme. So we can, upgrade the XUI test driver from version 2 to version 3 without worrying that it will pull in breaking changes for people installing the next patch version of Appium or something like that. So breaking changes will be isolated to the particular drivers or plugins or server that they correspond to, and won't kind of leak into people using them from other projects. So I'll give you a little demo of Appium 2.0. I don't have a whole lot already done in it, but I'll show you what there is. So I'm in my Appium development directory. So instead of typing Appium, I'm going to type node dot to actually activate the code here. So the first thing I'll do is I'll run driver list, and that will show me all of the available drivers. So I actually don't have any available drivers installed right now. So if I just start Appium, I get this message that no drivers have been installed. Use the Appium driver command to install the ones you want to use. Okay, well, that's what I'll do. So first thing I'm going to do is install one of the drivers that were listed as available. So I'm going to install the UI Automator 2 driver. And so here Appium will attempt to find it, and it's installing it silently here under the hood using npm. So this takes a moment based on my network, and of course with npm there's lots of files to download and unpack. I was very proud of this little loading animation with the dots here. Inordinately proud. I'm going to make it a Nyan cat at some point here. Okay, so it says driver UI Automator 2 successfully installed at this particular version, and now it gives me the UI automation name, or sorry, the automation name that I need to use in my capabilities to trigger this driver to be used for a particular session. And it also gives me the platform names that this driver supports, which of course is just Android. So now if I run the Appium server, I get a message that I have just one driver available, and it tells me what its automation name is. So I can also install drivers not just from their name. So that would be one of the Appium officially supported drivers. Oops, run driver list to show you again that the UI Automator 2 driver has been installed. Another driver is not yet installed. So what I'll next do is install a driver from GitHub. So I know that I have the Safari driver up installed. So I'll say driver install source equals GitHub. And then I'll just put in the GitHub organization and project name here, Appium/Appium Safari driver. So this is a driver for a Safari on Mac. And it's attempting to find it, and it's now installing it from GitHub. So again, this will take a little bit of time. Okay, now we have the Safari driver successfully installed, and you can see that it actually potentially has multiple platforms that it supports. So if I, again, list, I can even just list the ones that are installed. And there it is. And we see that the Safari driver was actually cloned from this GitHub URL instead of installed via npm. So this is all that I can really demonstrate right now. Basically, all I've got kind of working in a demoable fashion is this driver management system. If you're wondering how does Appium keep track of these different drivers, well, it now creates a kind of Appium home directory, which defaults to .appium in your home directory. And inside there's something called drivers.yaml. So we can take a look at this, and we can see that this is the little file that Appium has created that has a list of all the drivers that are installed and where they were installed from and their versions and things like this. So this helps with the management of Appium. So you could imagine that if you have an Appium setup that you'd like to replicate on dozens of different machines, you could just take, you could set it up on one machine, take the drivers.yaml file, make sure that it gets in the right place on all the different machines you want to install Appium on, and then just have Appium kind of rehydrate the installed drivers based on that YAML file. And of course, plugins will also be specified here as well. So it'll be a nice way to kind of have your Appium configuration in code rather than in a set of commands that you need to run as well. So with that, we are finished with our discussion of Appium 2.0, and we are done with my portion of the webinar. So thank you very much. And if you've liked any of the stuff we've talked about here, a lot of it has also been made available already as part of my newsletter and blog, Appium Pro, so please check that out. And I guess we've got about 10 minutes for questions.
Yeah, thanks, Jonathan. So just to reiterate, if you're interested, check out appiumpro.com, where Jonathan constantly updates with new material. It's really insightful. Right now, I think we have several questions that we can touch on. Jonathan, I also kind of sent it through you under the questions tab, but I can read them out.
Yeah, great.
So the first question is, so basically you don't need to use explicit weights for espresso? Question mark.
Yeah, great question. I mean, that's basically the idea. And in a lot of cases, I've found that to be true. There are some cases where Espresso doesn't really know that your app is doing something. It by default, it knows like if a view is transitioning to another view. I think even if maybe if a network request is happening, it decides that the application is in the middle of something. But some cases it might not know that your application is in the middle of something. So in those cases, I've still seen a few examples where it's safest to use an explicit weight. But I typically just write my test without explicit weights and then see if something breaks. There's also, in the case where something breaks, I then add an explicit weight around it. There's also the ability to actually write custom Java code that will teach Espresso about your application and have your application kind of let Espresso know when it's doing something. So that is still possible to do. It's just not part of Appium itself. It's something you have to do in your kind of app source code.
Next question. Can I run the backdoor Espresso feature on any APK resident on an Android device, even if I have no direct access to the source code? I'm thinking about various preload APKs that are part of the OS.
Yeah, great question. And unfortunately, I don't believe this is possible. The reason is that you have to have a debug APK. So it can't be just an APK that's already on the device or downloaded from the App Store. It has to be one that you built in debug mode. Otherwise, Espresso will not be able to automate it. So this is one of the downsides. It's kind of like the power that you get of looking inside the application is also a really big security risk. So Espresso only allows you to do it to applications that you have debug access over, whereas the other driver, the UI Automator 2 driver, can't look inside the application. It basically can do what a user can do, so there's no security concern. So it has basically full accessibility, access over all of the applications and aspects of the device.
Next question. For IoT, is there a gray box testing available in addition to the white box GPIO testing?
I wouldn't call GPIO white box testing, to be honest. I would say that white box testing would be like if I took my drum kit software and I created test code that just lived inside of my drum kit software and triggered drum noises without any kind of external input driving that. So kind of as if I were writing a unit test. That's kind of more of what I would consider a white box test. I would consider what we're doing with the GPIO stuff to be basically black box testing. We're just sending in electrical signals, which is all that the buttons themselves do. So we're basically mimicking a functional interface to the device. The only way we can make it more end-to-end is by building a robot that actually taps the different buttons the way a human would. But what we're doing with kind of getting one layer beneath the physical button tap to sending electrical signals, in my view, is exactly the same type of black box testing that Appium does with XUI test or UI Automator, where it's not physically tapping the screen, but it is getting kind of one layer below the glass, so to speak, and synthesizing that tap event as if a user were actually tapping it.
Next question, what are the main benefits of using UI Automator 2 instead of Espresso?
The main benefit of UI Automator 2 is that you're not limited to your own device that you have a debug, your own app that you have a debug APK for. You can automate any application, you can automate apps you don't own, didn't develop, you can automate various aspects of the device itself. Buttons and other things like that that just aren't really part of Espresso, because Espresso is designed for specific automation of a specific app. I think the Appium team is investigating the ability to combine both Espresso and UI Automator 2 into one session, so that you can kind of have the best of both worlds, so that when it comes to your application, you have this kind of gray box access to it and all the benefits of Espresso, but you also then have the ability to tap around other applications or other parts of the device. So this isn't available at the moment, but it's something we've been exploring, and looks like it might technically be possible. So that's kind of an experimental phase.
Great. Next question, do you need admin privilege to work with Appium 2.0?
No. So yeah, permissions for Appium won't change. I mean, some of the specific drivers have their own permission models. So for example, like we talked about, the Windows driver requires admin permissions, but that's not Appium itself. And all the driver installation and management happens in your own user directories. So unless you choose to put all of the drivers and plugins somewhere that your user doesn't have access to, Appium shouldn't require elevated privileges to do all of its basic operations.
Great, thanks, Jonathan. We have time for one more question. Let's kind of give it a few moments, but if there's no more questions, definitely, really appreciate you, John, for taking the time to join us today to kind of present on Appium 2.0. And for the rest of you guys, thank you for the hour. If you're interested in this webinar or other webinar related to Appium, please check back at headspin.io/resources. We'll be updating periodically with new webinars. But if there's no more questions, we'll let you have the rest of the day. So thank you, Jonathan, again. Thank you, everyone, for joining. Again, this webinar will be available, the recording will be available to everyone this next week. So thank you and have a nice day.
Thanks a lot. It's great to be here with all of you. Have a great day.